Okay, I'm working on this Magnavox amp for this customer, and I'm checking capacitors, and I just wanted to show this. This is just really, really weird. Anyway, I checked these three capacitors. You can tell they're loose here, right? Let me see if I can unhook this one, and we'll take a look at it, and you can see what's going on. I have my meter here set on a nanofarad scale, so anything on the left of the decimal point is microfarads. Anything on the right of the decimal point is hundredths or tenths or hundredths or thousandths of a microfarad, nanofarads. Okay, so I put leads on here so I can get to this. So if I select this left side, this, by the way, is you can see it there, it's upside down, but it's 250 microfarads at 25 volts. Of course, that's voltage DC. And if I connect to it, and you see the meter, we're at 0.46. So 470 nanofarads, or 4.47 microfarads. It's supposed to be 250 on the other side of that decimal point. Should be 250 microfarads. That's 0.48. It's leaky, so it's going to move all over the place. Really bad. Totally dead. It's like a dead short. Don't know what damage. This is the power supply. Don't know what damage they did. But to give you an idea, this also is a 25 volt capacitor, and if you look, I don't know if you can see that. Let's get the light on it there. If you look at that, you can probably see it says 220 microfarads at 25 volts. They don't make 250 anymore. They don't make 200. They make 220. But anyway, this is the same as that. Look at the difference in sides. That's where technology has gone from this to this. Now let me connect this one up to this for you, and like I said, this is a 220, so you can see we're at, that's just the air, right? The distance between these wires is nanofarads. But here, now it's connected. Now watch. Okay, you see the N went away because it's not point and a bunch of numbers. That all went away. It changed it to UF, or microfarad, and it's 224 to the decimal point. It's a 220 microfarad capacitor, plus or minus 20%. Well, you can see that it's pretty close. My meter's about to shut off because it's a battery there. But this is a IC, Illinois capacitors. I only use the best that I can get from Mauser or Granger. I buy all my capacitors from Mauser.com, and I usually get IC, Illinois capacitors, or Panasonic. They're not Panasonic, Nichicon. Either IC or Nichicon. They're the best, most expensive, but they're the best. And so you see how stable it is. It ain't flipping all over the place. It's 223.9. You know, I mean, that's 224, right? So, I mean, that's what it should be. This is the exact same capacitor, and you can see, oh, well, the meter shut off. That's to save on my battery, so I can turn it right back on. Now I'm on resistance. Now I'm right back on the NF, nanofarads. So if I put this back on there, 0.5, a half a microfarad. It's supposed to be 250. So, and again, since it rebooted, I'll show you still the same. $223.6, 224. So that's what it is. As it heats up, it'll change a little, but then it stabilizes. So it's 224 microfarads, or 223.5. It's rounds up. Okay, so that's that one. So let me just stick that back in there so I don't have to go following on the schematic where it goes. Let's look at this one. This one is hooked right here where I didn't solder it back. You can't check them in circuit. You have to disconnect one side so that you're just checking the component and not checking, you know, the resistors and everything that connects to it. Let's see if I can get it with this. Come on, let go. Alright, so here's this one. And connect the negative to the negative. Doesn't matter, you can connect it backwards, it still give you a good reading, but I connect them the way they're supposed to go, positive to positive. And look at 0.2, that's another 250 microfarad capacitor. Totally bad, totally bad. Now, I'll put that back in there so I remember where it goes. Fold it back over. Doesn't matter if I took it off. I can find it on a schematic. It's just a lot faster working on it if I put them right back where they go. Okay, that one goes there. So it's loose, but it's right in front of the contact. So let me just lift that out so it's not touching anything. And we'll check that. Now this one is a 200. If I move that little resistor, you see it's 200 microfarad at 20 volts instead of 250 at 25 volts. Doesn't matter, it's just a different capacitor, right? But it's the same company. So if we click the positive on the positive and put the negative back over here where it's still connected, it doesn't matter that one side's connected because the other side's not. It's like a flashlight. When you take the bulb out, there's no power going. Or turn off a light switch, there's no power going because there's no circuit. The only circuit is through my meter. And you see that this one is reading 3.3 microfarads. So 3 1/3, almost, you know, around a little over 3 microfarads. It's a 200 microfarad capacitor. That's down to 3. I have never seen capacitors this bad, ever. I work on antique radios from the 20s, and capacitors are in the microfarad range, and you know, usually they didn't make high microfarads back in antique days, the 30s, 20s. They just didn't have them. So you know, you might have a 22, or you might have a 18 or a 16 or an 8 or a 6 or a 4, but like say it was a 20 microfarad or a 18 microfarad, it would read around 4 or 5. Even if it was bad, it would read about a third. Well, a third of 200 would be 66. It's nowhere near that. It's dead. I mean, it's completely dead. And so here's the issue. There's no manufacturer's name on these capacitors, by the way. That goes in that little hole there. So I don't know who they are. They've got like a triangle symbol, and that's all. There's no name. So I don't know who these capacitors were made by. But they're all the same. Okay, let me shut my meter off and get it out of the way. You can see here, these are the power supply ones, and I'm going to move the camera here a little bit. I'm going to tilt it down, and you can see this board, the same capacitors. See them? Same capacitor. These are smaller values. This is a 5 microfarad, probably a 5. This one's a 50. It's a little bit bigger. There's two here by a different company. They're actually Nishikon. Check it out. Okay, so those are good capacitors. Let's see what they read. I can't really get a reading because they're soldered to the printed circuit board. This one's saying 100 microfarad at 10 volts. Probably won't be able to read it at all because it is connected to the printed circuit board. Let's see. Let's see if we get any kind of reading at all on these. They're both the same. They're both 100 microfarad. Let's see, I think I can get to that one. All right. Let's see. It may not read it at all. It may give me a faulty reading, but yeah, it's not reading it. It's already up to 1,000 farads instead of microfarads. It's at millifarads. Can't read it because it's in circuit. But I bet if I was to unsolder them, they would have some reading. They'd still be bad because they're so old. This is a 1962, 63, maybe 61 amp. So they're 70 years old. But at least those are Nichicon. But these things, I don't know what they are. They're just some generics that Magnavox used. Now this board here also has them. Let's see if we can turn this around. And oh, it only has a couple. Has two Nichicons. They're up here. Let's see if I can zoom you in a little bit. I don't know, I might not be able to do that. But anyway, up here at the top board here, there's these two. They're the Nichicons. Again, they're old. And then there's a blue one here up at the very top. And then there's another Nichicon. But they're all going to need to be replaced. Down here on this bottom board, you see we have another blue one here. Get a light in there. See, another blue one there. And we got Nichicons here, Nichicon here. They all need to go. They all need to be replaced. They're all old. They're out of tolerance. They're not the only ones. There would be some up in that can up there. This can here. Now, the next thing I need to check is your output transistors, because when those things went, they shorted. There's no telling what they blew out. By the way, this is the main electrolytic here. It's a 500 microfarad, and there's 1,000 microfarad and a 500 microfarad at 30 volts and 20 volts respectively. Only one of them is being used. The other one is not used. It's just they got a deal on these, so they come two in a can. They only needed one, so they hooked up one. That's definitely bad. I knew that was bad. I didn't even bother checking it. Those things definitely go bad. That's a constant problem. But again, I leave the can, so for aesthetics, it looks nice if anyone works on it. And what I do is I cut the wires off the bottom of the can and connect them on a new capacitor. It'd still be a new capacitor. They'll be a little bit bigger than, it'd be a little bit bigger than this, the one that will replace the one that's in there, but not a lot bigger. Even if you go to high voltage, which is a low voltage, 35 volts. Let's see. Here's one that's 200. Yeah. This one is these. I don't know if you can see these. These are 22s at 250 volts. And you see they're not much bigger. They're still kind of small, right? But that's a 10 times bigger than the one that's being used in this can. So they need to change. I don't know if they burnt the transistors. If they have, then I got to find these power transistors. There's also transistors on the board. I need to check those. But right now, just in capacitors, we're looking at a hefty amount. And so, if these are bad, these can range around $20 to $30 a piece. Sometimes you can get them cheaper. They don't, most likely not making them. They might have modern replacements. If not, I have to buy new old stock. Um, so anyway, let me pull one of them out and check it, and then I'll let you know when I call you on the phone. I'll let the customer know when I call them on the phone, and let them know what's going on. And anyway, that's where I'm at. So then I got to check these coils. I got this wired from above so it can't fall, but I like it on this because it makes it easy to work. I can just turn it around, you know, gently. I need to check these two coils. The transformer's fine. I checked it. It's putting out power. These are most likely fine too. They don't look like they got hot or burnt or anything. I think these probably died more in shelf life, but you never know. If somebody plugged it in and these jokers were shorted, they could throw voltage where it's not supposed to be, and you know that can cause problems. I did check resistors and got strange values on resistors, but that's because they're tied to these capacitors. So anyway, I just wanted to make a short video. For those of you who are learning electronics who are watching this video, just be aware that this is what can happen with capacitors. And by the way, I put a little X on them as I'm going. Not that it matters. Right now I won't do that anymore because I know they're all bad. I checked 3 and they were all worse than I have ever seen a capacitor to be. So these are disasters. They're dead. And what a capacitor is, for those of you who are still learning, it's 2 pieces of foil that are wrapped together like a Swiss roll or like a cinnamon roll, whatever. They're wrapped together around each other. They don't touch, they just wrap together. And if you unwrap them, it would be like 2 real long sheets that are separated, that are not touching. And they have an electrolytic between them, chemical between them, that allows current to build up on those plates. So one of them connects to ground, and by the way, this is a positive chassis, so everything that connects to ground, like this one here, you see the positive goes there, and you can see back there, probably. Yeah. This one is positive, it goes to this terminal strip, and you can see back there that it's soldered to the chassis, because the positive is on the chassis on this model. But anyway, those plates, one plate, one of those 2 plates goes to the chassis, the other one carries the voltage that provides voltages for the circuits. We have voltage divider resistors that divide the voltage into segments, and then the capacitors act like batteries. They get charged and discharged as the voltage goes up and down or changes, and they hold the voltages at a current position in a power supply. Now, they have a different function in other circuits. They're used for frequency control, you know. Anyway, so, but in a power supply, they're part of the voltage smoothing. They get rid of some of the ripple on the on the DC line that you're using, so you don't get that hum. When you get a hum in a power supply, it's because the filter capacitors are bad. But when filter capacitors short, which they shouldn't do, but when they do short, and then they allow DC through. A short is those 2 plates actually somewhere touching. You know, the chemical between it deteriorated completely away, and the plates touch. And that's a big no-no. That's sort of like taking a wire and sticking it in one side of your AC outlet and sticking the other end in the other side of the AC outlet. You're going to get a nasty spark, and you're going to trip the breaker. Well, in here, you're not going to get a nasty spark because they're already connected, but the power is still going to jump through. And you're not going to trip a breaker because there is no fuse in this unit anyway, at all. But there's not, they're just parts of the circuit. So what they do is they send voltage directly to parts of the circuit that are not designed to handle voltage, and they burn them up. Now, usually you can see that on the boards, and I don't see anything on the board that looks bad. However, transistors, like these power transistors and these little tiny, small little can audio transistors, these little guys that look like little hats on legs, those things cannot, this one here, this one right there, they cannot handle voltage, spikes. So if a large amount of voltage is short-circuited through a capacitor to one of the leads, and those transistors, it just burn them up. And so then they got to be replaced. I'm not too concerned with the cans, the little transistors. I mean, I am, because, you know, add an expense, it builds up, right? But the bigger expensive items, or sometimes irreplaceable items, are the transformers. In this I could probably find substitutes that would work, even if I couldn't find the exact ones. But the transformers, the power ICs, power transistors, these here are IC chips, the beginning of IC chips. This is an integrated circuit. You have one here, looks like a wafer. You have one here. You can see here how kind of bulgy they are. That's the way they're made. That's not a negative thing. But inside is a bunch of little resistors and capacitors. Those are hard to find. In fact, they could be irreplaceable if they're bad, with the same thing. So sometimes if one's bad, you have to actually rebuild it with regular resistors and capacitors in its place. But these are the beginnings of IC chips that are in computers. So you got one here, you got one here, one here, one here. And there might be more on the other side of that top board. Those can't handle high voltage spikes either. So, you know, there's no telling what damage the capacitors have done. It's not likely that they're bad, but you never know, all right? I mean, you know, as you're working, you have to fix point A before you can test point B. So sometimes you can't even test a component until it's energized, and it has to be energized from point A, which has to be functioning properly. So a lot of times is really complicated and or time consuming, and time is money, right? To try to figure out every single component that's bad. It would take me just as long to go through and test every single component as it would be to restore the unit with with the parts that I know are bad. That takes a lot of time. But as I go through, I check what I can. Like while I'm changing these capacitors on this board, I'm checking the resistors, I'm checking these as best I can, I'm checking the transistors, you know. But just to go through and check everything and come up with a total is not feasible, because you have to take them out to check them. You have to disconnect them from the circuit, and that takes a lot of time. So if you take it out and it's bad, you want to put a good one in. Well, there's no way to wait for authorization on every single little thing. So that's why I make these videos, to give you an idea of what we're looking at. Right now I can tell you all the capacitors have got to go. That's part one. I'll know before I talk to the owner whether or not the power transistors are bad. I'll know if these coils are okay. Things like that, or if they test okay. You know, you can't really, again, even with those, you don't really know for sure. You know 90%. Check them, they ohm out, they seem okay. If the schematic tells you the resistance that it's supposed to be and they're within the ballpark, then you know they're okay. But sometimes you can check them and they ohm out, but they got shorted loops inside and they're not okay. So just because they ohm out doesn't mean that they're accurate in value. So anyway, that's where I'm at, and that's what we're up against, and I just wanted to make a video so it would be available. Thanks for watching.